This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your host, Radio Joe Hughes, and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day, wherever you're listening from, and welcome to Indoor Air Quality Radio Plus, IAQ Radio Plus. It's Friday, March 8th, 2019. Today's guest is Dr. Parham Azimi, calling in from the University of the Illinois Institute of Technology. He's a research associate there, and we're going to talk a little today about particulate matter and mortality, and just get a little more interesting. Some other interesting topics we're looking forward to. Before we get started, let's thank our sponsors.
IAQ Radio Platinum sponsor is John Don Products, where restoration and abatement contractors shop. Visit them at jondon.com. That's JONDON.com.
I also want to thank our gold sponsors, Particles Plus, Healthy Indoors Magazine, Gray Wolf Sensing Solutions, and AEML Inc. Laboratory. And of course, our association sponsors, the Indoor Air Quality Association and the Restoration Industry Association.
And now you can win a cool prize. It's time for the IAQ Radio Trivia question. Be the first to correctly answer. Simply email your answer to czlotnick@cs.com, or if listening live, just text your answer from your computer. And now, here's the Z-Man with this week's IAQ Radio Trivia question.
Hello, everyone. Congratulations go out to Tom Barnes III, Greenville, South Carolina, who was first to identify Bill Blackman and Scott Mooring as the two Texas businessmen who in 1968 founded the business, which would later become known as Steamatic. The IAQ Radio question for today, Friday, March 8, 2019, has been sponsored by Ideas, the solution chemistry company, providing unique solutions to odor removal, surface cleaning, and decontamination problems. Here's today's trivia question. Name the legislation in the year it was created, which created a research and regulatory program in the United States Public Health Service. Back to you, Joe.
All right. Today's guest is Dr. Parham Azimi. He is a research associate in the Department of Civil, Architectural, and Environmental Engineering at the Illinois Institute of Technology. Much of his research work has focused on the fate, transport, and control of indoor aerosols of indoor and ambient origin, chronic health impacts of fine particles in various microenvironments, and energy performance of residential and commercial buildings. We look forward to a great interview today. Hello, Dr. Azimi. Do we have you on?
Hello, Joe. Thank you for having me. Hello, Cliff. Very nice to meet you guys, and thank you for inviting me. It's a pleasure to be here and talking with Indoor Air Quality Radio audience. Thank you for.
Our pleasure. I'm curious, before we get started, we always like to get a little background on our guests, and you have an interesting background. You came from, came to here from Iran, and you're now at the Illinois Institute of Technology. How did you end up being, first of all, what led to your interest in indoor air quality? And then how did you end up at the Illinois Institute of Technology?
Thank you. So I have I got my undergrad degree in civil engineering. And then I, because of my interest in environment, so I continue my education during master in environmental engineering. Then 7 years ago, when I wanted to decide my path for continuing my PhD, I had different options. I wanted to come to the United States. So because I had relatives in Chicago and Boston, I was between these two cities. Eventually, I came to Chicago and started my environmental engineering program. Then, as soon as I started environmental engineering program, I was lucky that Dr. Brent Stephens, my advisor during my PhD and my supervisor right now, he joined IIT as well, and I was his first PhD student. I decided to work on indoor air quality because I was more interested in physics and chemistry. So between the different fields of environmental engineering, indoor air quality, and aerosols, basically they have more physical reactions than chemical reactions. That's why I decided to choose indoor air quality and join that group. It's been 7 years after I joined a built environmental research group. We call it BERG, and we call ourselves Bergers. It was like an amazing experience. I really enjoy it. We did like a different projects, researches, a wide variety of like researches that I really enjoy it.
What how much awareness of indoor air quality is there in Iran? I mean, is that a topic that people talk about, or is it more of an academic kind of thing?
So actually, when I came to when I started my this field like 7 years ago, no one really knows about indoor air quality. And when I was telling people that I'm like focused on indoor air quality, people are saying, "What is it? So what exactly you do?" But recently, it's getting more awareness. Actually, I was talking with my family in Iran. They wanted to get a permission to build a new house in Iran, and it seems that it is one of the requirements that you have in Iran recently for some cities to make a house. So you have to do, you have to consider indoor air quality. You have to ask consultants who are focused on indoor air quality to design your home in a proper way that you have like a healthy air. So recently, it is getting more popular in Iran, and in United States, it's very popular as well. And I think the attention to this topic is getting more. It's getting more attention.
What type of construction is dominant in Iran? Do you have? I'm wondering, are there basements? Are there crawl spaces? Were these new things to you when you started looking at indoor air quality here in the United States?
So one thing that I really like is new to me. Houses which are built with wood, you know, that was like something that we don't do it in Iran. And when you have, pardon me?
Houses built with a what?
With wood, like wood structures.
I see.
So usually in Iran we are using concrete or steel. We are not using wood. And when I came here, we had a like issue with mold in the United States. A lot of older homes they had mold issues, and a lot of consulting companies trying to find the sources of the mold inside home, which was like completely new for me, and it was one thing very different. But crawl space and basement, it is exists in Iran, but mostly basement, not crawl spaces. We don't like. We usually have like we either have a basement or it is like on the ground, but not crawl spaces. It's not like a very popular in Iran.
Okay.
As I said, the structures are mostly steel or concrete. In very small like villages, or you may use brick for making a home, but it is not that. I think recently it's not that popular, particularly newer homes. Because Iran is located in some area which we have lots of earthquakes. So the standards or like a regulation asking people to use steel or concrete building.
Okay. You came to our attention because of a paper, a framework for estimating the U.S. mortality burden of fine particulate matter exposure attributable to indoor and outdoor microenvironments. It's a mouthful. But then I started looking through your CV and some of your other work, and I thought, let's start with a couple of other topics because I find those very interesting. What you've also been part of an ASHRAE Technical Committee 2.4, particulate air contaminants and particulate contaminant removal equipment. And we deal a lot with remediation of indoor environments here, and we talk a lot about, contamination removal equipment. And I'm wondering if you could tell listeners a little bit about what that technical committee is doing and what the purpose of it is and what they are doing.
Yeah, sure. ASHRAE Technical Committee 2.4 is focused on, as you said, our particulate contaminants. And they are focusing on both solid and liquid contaminants, and the way that we are measure them, the properties of them, how they are affecting people, human, and also even materials like our furniture, like sculptures, this kind of stuff that we are putting at home. They are focusing on that, and also we are talking about the methods that we can remove these contaminants from home as much as possible. We are looking for a more efficient way of removing particulate matter from home, which are more energy efficient and more economically defendable. So we don't want to ask for tons of money to spend. So we are focusing on energy efficiency and economic sides of that as well. We are not talking about the stuff that we are not talking particular toxicity. Maybe we are not focusing very a lot on that. And yeah, that is and we also talk about different ventilation systems that we are using. So different stuff.
Okay, and so is there any discussion about room size, air filtration devices, little air filtration devices, or is it more focused on the mechanical system and ventilation? And also, what about particulate? We use these things we call air filtration devices during remediation. Is there any discussion of that?
Yes, definitely. That is a part of the methods to removing particulate matter. Air filtration devices, ventilation devices, all of that, or air handling units, or HVAC systems, these are all part of the methods that we are using for removing particulate matter from indoor air.
Okay. And are you looking at ways of testing that equipment? So how do we test an air filtration device properly?
So there are different ways. We can do it in the lab, we can have a custom built HVAC systems and put air filters and measure in the lab, measure a concentration of particulate matter before and after the filter and find the efficiency of air filters for removing particles. That is a laboratory way. The other way is in the lab we can inject some particles and then use inside the chamber and then use a air filtration system, even a air handling unit or something like that, and then see how fast it can reduce the concentration of particulate matter, and then using the slope that you are calculating or monitoring, you can estimate the removal efficiency of that system. It is used in the lab. Plus, we also do the field measurements.
Oh, you are?
In
Okay.
the field measurements, we are kind of more limited. Usually, we are measuring the concentration, indoor and outdoor concentration, and based on the decay rate, we can estimate what was the emission rate, what was the removal efficiency rate. using different using mass balance equations or number balance equations that we are applying in a one environment.
Okay, that sounds like a very wide-ranging committee. They've got a lot of. How long has that committee been in place? Do you know?
I don't know exactly when they started. So I joined them about like 5 years ago, but I don't know when they started. So I'm not sure when they started yet.
You also, I noticed a paper on modeling the impact of residential HVAC filtration on indoor particles of outdoor origin. It seems like that kind of leads to the paper that brought us to bring you on today. Can you tell listeners a little bit about that paper and what you were looking for there, modeling the impact of residential HVAC filtration on indoor particles of outdoor origin? That's a mouthful, but maybe you could tell listeners a little on what you did there.
Yes, sure. So that paper, we got a grant from ASHRAE for working on that paper. In that paper, we consider different type of homes in different locations in the United States. We consider different cities, I think close to 20 cities in the United States with different of homes, and then we consider different type of HVAC systems or like a filtration system for these homes. And then based on that, we assume that there is, it was like a modeling effort. So we had some like assumptions, which was like not very accurate for actual light, but we assume that there is no sources of indoor air pollution, and we just like focus on outdoor. And based on the penetration factors of the homes and air exchange rate and HVAC system runtime, we estimate what is the impact of different air filtration. You know, if we put different MERV filters in the system, how much they can reduce the concentration of particulate matter in the air. So it was like a modeling effort, and we consider different weather zones in the United States. So in more moderate places and where the HVAC system is running less, so the impact would be like a lower. But when we are talking about like a more harsh weather areas, either warm or cold, when the HVAC system runs more, so you can see the impact of like HVAC filtration is improving. So it was based on these assumptions that HVAC system is working when it is either heating or cooling, which is like valid for most of the homes in the United States, because usually people they don't put the like a fan only mode very often. They use their HVAC system when they either want to use heating or cooling. So,
and
that's what I like about it.
How effective are existing HVAC systems in removing these particles that we know come from outside, get into the indoor environment?
It is very depend on the HVAC filter, that air filter that you are using in the HVAC system. So if you are using a proper filter, air filter, it can be like effective. It can like reduce like more than 50. It depend on the runtime, airflow, recirculation rate, and this kind of stuff. But usually it can be very effective, as you can almost as much as like a 70% they can like reduce. Okay. But if you are not using a proper air filter, it doesn't help you a lot. So maybe you are using these like air filters, which you can like when you hold it in front of your face, you can like see through it. So we are saying this, so like a kind of air filter is just like for catching like insects or like flies. You know, it doesn't like catch particles. You know, it's not very effective for that. And unfortunately, in field I see it a lot, that people are like using these, and like companies who are like installing HVAC system, they're saying, oh, because you don't want a lot of like a pressure drop, use this kind of filter. So it is not like a really, yes, it is, they have a lower pressure drop, but it's not like a help it wouldn't help your health.
Won't help. But you did find up to 70% reduction in some cases. Let's say they had a MERV filter, they ran the system, you know, pretty regularly, and you could see as much as 70%.
Yes.
Interesting. Now, what percent of our indoor particulate, and I know this varies and it depends, but a ballpark idea, what percent of that came from outside?
So it is very depending on the type of the home. So if you are staying in the more moderate zones with people open their windows a lot and they let the natural ventilation happen. So you see that a lot of air pollution is coming from outside. But when we are talking about a Chicago area, when during winter, when people closing their windows, there is no a ventilation system. So lots of these pollutants actually coming from home. So I see a very different numbers, you know, as low as I would say 20% or 30% coming from outside to almost 80%, 70% from outside. So it is a wide range, and I see a lot of that very depend on home characteristics, human activities, how they open and close the windows, how often they use the HVAC system. It's very different. Okay. Or if they are cooking at home or not, you know, if you cook or if you smoke at home, there's lots of that proportion of pollutant is coming from indoor sources. So it's very different.
I noticed in several of your papers, you did not use homes where they were smoking in the indoor environment. I assume that's because it just skews the results so high that it's easier to just remove those people.
Exactly, and lots of these numbers that they are using for mortality, they are adjusted for lower concentrations. So they are based on the outdoor air pollution, and they are so how they calculate these numbers for mortality rate. They are assigning or a regression or linear regressions or different type of regressions on the changes in the outdoor air concentration, and based on that, they in a long way they see how much the mortality changes, and they find these mortality rate values or beta values. So they usually focus on lower concentration of air pollutants. So when we are talking about a high concentration coming from smoking, so we cannot actually using those numbers. So you need numbers which adjusted for those concentrations.
Interesting. Now, before we go into the mortality and that particular study, indoor or outdoor comparison, I noticed another paper you did on 3D printers. And, you know, you were talking about indoor sources of contaminants, of particulate. And I wondered, first of all, how much of a source is a laser printer you know, I guess a laser printer is the most common. I've got one sitting over here right now. What kind of exposure do people get when they're using a laser printer in their home?
So again, it is very different, and it's based on how often they are using it, how far they are from it. It can be very different, and we are talking about mostly for laser printer and 3D printers. We are talking about ultra fine particles, which is not it is not based on the mass, it's based on the number concentration of these number concentration of these particles.
Mm-hmm.
So ultra for audience, if I'm pretty sure they are familiar with that, but when we are talking about ultra fine particles, we are talking about particles less than 100 nanometers. Laser printers and 3D printers, they are usually emitting lots of ultra fine particles. And I was in if we are talking about like a closed small area, the concentration could be like going as high as like 1 million numbers per centimeter cube. I've seen this number in like a very small areas, but usually when we are talking about like a small homes with like a living room with one printer working like casually, I think like 20,000, 30,000 numbers per centimeter cube. If you want to have some idea what is like a regular concentration of ultrafine particles at home, so it's very different. It's changing a lot when you are cooking or doing that. But I usually get like a number concentration between 8,000 to 15,000 when there is no like a significant source. Sometimes I get a 5,000, but regularly between 8,000 to 15,000 number per centimeter cube we are talking. And when we are like operating a laser printer, this number can be like a double or triple when we are using one of the during like that 5 minutes. So it depends on how often you are using your printer. If you are like copying and like printing a lot, so that would be like for a longer time. But if you are like using it for just one or two copying, printing 1 or 2 pages, so it could be like a lower exposure.
And of course, it would also depend if they had ventilation in that area. I don't think many people do in their home, but
no.
You know, unless you put it in your
I never seen it like at home that they put a hood on the top of their 3D printer or laser printer. I never seen that.
Well, what about the 3D printers? Do they release more particulate, more of this ultrafine particulate than a regular laser printer?
It depends on the type of filament that they are using. Nowadays, 3D printers use a wide variety of like filaments. They call there two of them are more popular: ABS and PLA. PLA is more like it's coming from more natural like sources, and the emission rates of PLA filaments are lower than ABS, but I would say that laser printers are like between like PLA and ABS. The emission rates from like it's almost the same as ABS filament.
Okay, and Cliff, before we go to halftime, was there anything you wanted? I haven't been able to follow the chat. I don't know if there were any chat questions you wanted to ask Dr. Azimi, or if you had any questions of your own.
No, I just had one, Doctor. In studying the HVAC systems, you know, some of these systems draw more, you know, they run it, they're moving more CFM, the blowers are bigger, you know, particularly in some of the older systems. And I was wondering whether you studied, or, you know, how that blower system can negatively pressurize the house and draw more contaminants in from the outside. You know, like what role that plays.
Yeah, it depends if it is like a recirculation or ventilation. So most of these HVAC systems that I've seen at home, they are recirculating air.
Right.
So they are getting the air and putting it back from the other register. So they shouldn't make lots of like a negative pressure on the home. So it shouldn't like change the infiltration of outdoor air a lot if it is like a recirculation only. Okay. But if you are like talking about ventilation, yes, so it could have impact on concentration of outdoor air pollution, so they come inside. So that's why we are like trying to if our envelope is tight, so it can these particulates can filter properly before they come inside. But we are preferring to have a ventilation system which we have like a control on the source of outdoor air. So we get the outdoor air from some pathway that we can like filter them before they get inside. Well, yeah, as I said, in a regular homes that I usually see. Residential building, they're mostly like recirculation, so they don't impact on the like air pressure.
Okay, thank you.
Before we go to halftime, I have a text came in private. There are also, I guess, inkjet printers as well, and then you got laser jet, I guess, or laser printers, and then you've got the 3D printers. How do the inkjet printers compare to the laser printers? Are they producing less particulate, more particulate, different types of particulate?
I haven't tested the jet printers, so I cannot like answer to that question like specifically. But it would be depending on like type of materials that we are talking. I have to say I did some measurement on like a laser cutters when they are like cutting a wood or this kind of stuff. So those laser cutters, they are emitting particle and also VOCs. And I have to tell you what one of the difference between like a laser printer and like a 3D printer. 3D printer emitting lots of VOCs as well, volatile organic compounds. So which can be like more harmful than even particles. I
would imagine also, and correct me if I'm wrong, I've never had a 3D printer. I don't know a whole lot about them, but it seems to me that you would be running that for a longer period of time than a typical laser printer. Is that true?
That's completely true. So when you are like want to like print something as small as like this, it's very different. It could be like 3 hours, 4 hours of printing.
Okay.
And when you buy for kids, so kids are like very interested to see how it is like printing, and they are just like sitting like close to it and watch it for a long time, and it's like printing, and it's just like breathe it, So fortunately, there are lots of companies starting to put enclosure for it. They put like interior filtration for it. Some filters have like a boost for particles, and also it has like active carbon to get VOCs as well, which is like a great. And we are not like against using 3D printers. We are saying that when you want to cook, you cook under a hood. So you put the ventilation for when you are cooking. So it is the same as for 3D printers. You have to be careful about them. You have to provide proper ventilation system for that. Actually, when the way that we got this project, it was about when one of the employees of one of the companies who has like many 3D printers, and they put like 6 or 7 3D printers inside like a small room, and he complains to us. It was like one of our classmates. He complains to us that whenever I work in that room, I get a headache. And I can like it not to do it. So they suggested us to go and do the measurements, and when we went there and we do the measurements, we saw that lots of ultrafine particles coming out of that, and it was our first paper, which was like the first known paper regarding emissions of 3D printers.
Okay, very interesting. Yeah. All right, well, when we come back, we're going to stop. We're going to thank our sponsors, and when we come back for the second half of the interview, I want to get into some detail about the paper we were talking about here on estimates of U.S. mortality burden attributable to indoor exposure to fine particulate matter of both indoor and outdoor origin. It's a mouthful, but we'll be right back with Dr. Parham Azimi.
Thank you.
The sponsor is John Donne Products, where restoration and abatement contractors shop. Visit them at jondon.com. That's JONDON.com. Gold sponsors are Particles Plus engineers and manufacturers of feature-rich particle counters and air quality monitoring instrumentation. Learn more at particlesplus.com. Count on us. Healthy Indoors Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions available at healthyindoors.com. And AEML Laboratories, free FedEx shipping, great pricing, same-day results, and never a rush fee. Learn more at AEMLinc.com. Gray Wolf Sensing Solutions, who use advanced sensor software technology and embedded computers to provide superior environmental test instrumentation. Visit them at wolfsense.com. Association sponsors are the Indoor Air Quality Association, a multidisciplinary organization dedicated to promoting the exchange of indoor environmental information through education and research. Learn more at IAQA.org. And RIA, the Restoration Industry Association, the granddaddy of the restoration industry. Network with leaders. Learn more at restorationindustry.org.
I also want to let listeners know we just got another association sponsor. Actually, they're a professional society, I believe is what they're called. The Cleaning Industry Research Institute will be joining the IAQ radio team here very soon, and it's great to have them. We've had John Downey, their executive director, on the show several times, and I look forward to talking to John more and doing some shows on their they're putting out a new peer-reviewed I guess would be a magazine essentially for articles on cleaning and cleaning industry research. So looking forward to having John on and some of the people that are authors in that new journal. Anyway, let's go to the framework for estimating mortality of fine particulate matter. I guess let's start with this. It looks to me like you started with the outdoor. I mean, there's pretty good information on outdoor particulate matter and mortality. So maybe you could just kind of fill listeners in a little bit on that. First of all, when you say mortality, what are we talking about with respect to mortality? Secondly, how did you break down the outdoor particulate? Where did you get your outdoor particulate numbers from?
Sure. So when we are talking about mortality, we are the way that they are usually measured these mortality rates. They based on like a census data, they know that how many like a death was happening in the United States in different regions. And then they are removing the accidental event, deaths, like for like a car accidents or like a work accidents or this kind of stuff. So they remove that part, and it just remains like a death related to heart attack, like a cancer, and like a respiratory problems. So when they have those rates related to that one, and then they compare it with the outdoor air concentration in those like in different regions or different cities. And the studies are showing that it was like a linear relationship or correlation between like number of deaths and PM concentration. So that's why they are saying that the PM, so they are saying, oh, when there's like a linear or direct relationship between like a outdoor concentration and number of deaths, which is not like, because of different diseases. So it says maybe particles are responsible for this increase in the number of the deaths. So that's the way they are doing it. Yeah, I can talk about like outdoor air, how we measure it. But you have a question?
Let's start with this. This particular study is for the United States only, as I understand. Is that correct? You're looking at the United States. What? Yeah. And I don't know. I didn't prepare you for this, so if you don't know the answer, that's fine. How does the United States rate with respect to, and I think we're talking about PM 2.5, right? And below, or are we talking,
Yes.
okay, PM 2.5. How do we rate compared to other countries? You know, you see that China and India and some of these other countries have what I assume are very high numbers of PM. Are those like double what you see in the United States, triple, 4 times as much? How do we rate comparatively?
So fortunately, we are in a good shape, kind of, you know, the highest concentration that I see in the United States, it could be like about, as you say, I don't have this number in front of me, but from my mind, I think it's like the highest number would be like a 40 or 50 micrograms per meter cube for PM 2.5. It's very depend on like a different season, different like a location, but I rarely see something more than like a 40 or 50. Which the standard is telling that the standard is like a 10 microgram per meter cube for like a PM 2.5. But in cities, in other cities like a Beijing or like a New Delhi or Tehran, we are talking about like a 300, you know, microgram per meter cube. It's a lot higher, you know, it's a lot higher in those 300, 350. In some days that they have to like make they close the offices and schools, and they are asking people to not go out of their home when they are like passing like these crazy limitations of like crazy concentration of particulate matter in the other countries. Yeah.
So
in Iran, I see that a lot.
These numbers could be as much as 10 times higher. I mean, from 30 to 50 up to 300 or more. What do you know off the top of your head, in the Western United States during the wildfire? We had a lot of wildfires here recently. What kind of numbers did you see then? Do you know that?
I don't know that, but it was definitely increasing the concentration. And actually, I don't because it's pretty new, so I don't see like I don't completely sure that this data is using in any journal papers yet, but definitely you can like check it in the like EPA website and the other sources. They are reporting that, and if you check at the like a date, so you can see that. So yes, when people are seeing like a smoke, so definitely the concentration are like very high, and it could be like it could be as bad as like those like cities that I mentioned. So maybe like 300. I'm not sure about the number. Yeah.
Now, the other thing you're trying to do here is determine the particulate matter exposure attributable to indoor and outdoor. So you're trying to, and it's got to be tough to do. You're trying to determine, okay, how much of this particulate matter in my indoor environment came from outside and how much came from inside. And as we said earlier, you excluded homes where they were smoking because that would have just made it almost impossible. How do you do that? I mean, I know it's probably a little lengthy, but if you could kind of give us the short version of how you try and tease out the difference between the indoor and the outdoor particles.
Exactly, sure. So in that like a paper that you are talking about, we are using a model. So we write a mass balance model for different homes based on the home characteristics and see how much of the outdoor air pollution is coming inside using like a usual mass balance equation, considering different penetration factor, infiltration factor, HVAC system runtime. So we estimate the proportion of outdoor air which is coming from inside. And then in that model, we introduce some emission rate, which is like from indoor sources, and then so we add those numbers together, and we find the total concentration of particulate matter, and we know that how much of it is coming from outside and how much of is coming from inside. But as you said, in a practical way, we cannot do the modeling. So usually in a field measurements, what we are doing, we try to minimize the indoor sources as much as possible. For example, we are trying to we make the people to leave the house to not walk or suspend the thing. We are turning off the HVAC system to not recirculate the air, and then we are trying to not having indoor sources cooking or the other different sources. So we are omitting or removing all of the indoor sources, and then we see or we monitor outdoor concentration, indoor concentration together. So when based on the changes in the outdoor concentration, and then we monitor how much the indoor concentration is changes. When we are comparing these changes and we pass it through the model, so we can see how much of the outdoor is coming inside. So when we know that how much of outdoor is coming inside, then we can have indoor sources, and then we see how much those sources is adding a concentration to that. So that way we are finding the portion of indoor sources and outdoor sources in total concentration of air particulate matter at home.
And that helps you build your model?
Yes, the model that we are doing is a framework. So the reason that we start this framework, lots of these epidemiology studies was based on the outdoor air pollution. None of them considering indoor exposures. But we are saying that 90% of the time we are staying indoors. So we have to see how much of particulate matter people are exposing inside homes. So we are saying, okay, when we are living in a city which outdoor air concentration is increasing 10 microgram per meter cube, it is really changing inside homes 10 microgram? No. So because we have infiltration factor of 0.6, so inside home the concentration would be changed 6 microgram per meter cube. So that's why we are saying that we are considering different microenvironments, and we see how much actually people are exposed to the PM2.5 in different microenvironments, and based on that we can find actual mortality. So we are saying that we are not exposing to just outdoor sources, we are also exposing to indoor sources. The reason that we use the term of framework, because we are using lots of assumptions in our model. For example, we assume that particles from indoor sources and outdoor sources have the same toxicity, which is not some papers say that indoor sources are more toxic, some sources are saying outdoor sources are more toxic. So we don't know which one is correct. So we just assume that they are equal to each other. So that's why we say that still we don't know the exact numbers, so let's have it like a framework. In the future, if we get a better number, we can put it in the framework and get a better estimate of mortality. So that's why we use a framework term for that.
Interesting. So it's really going to help future research more than anything. It's not necessarily telling us a great deal well, it's telling us something right now, but I mean, it's really a kind of a foundation on which to build. Is that accurate to say?
I would say that it's accurate because we are comparing with other existing studies to estimating the mortality, and we are in the same range. And so it's accurate, but it can always improve.
Now, I noticed in here it said, let me get to this. All right. Our best estimates of the U.S. mortality burden associated with total PM2.5 exposure in the year 2012 range from 230,000 to 300,000 deaths. That kind of gets your attention right there. Indoor exposure to PM 2.5 of outdoor origin is typically the largest total exposure, accounting for 40 to 60% of the total mortality, followed by residential exposure to indoor PM 2.5. So of that mortality of 230,000 to 300,000 deaths, 40 to 60%, and I hope I have this right, is from the outdoor, from the
Exactly.
PM 2.5 coming from the outdoors, but then you have another 30 or 40% coming from the indoor exposure.
No, these are coming. So they are outdoor sources. So 40 to 60% are coming from outdoor sources, but still the most of our exposure to outdoor sources are indoor.
Okay.
Yeah.
So then, conversely, 40 to 60% are also from indoor sources, right? I mean,
yeah.
Okay, interesting. And then you had two methods, I think. Can you tell us a little bit more about that? How you applied that model framework, and you used two different methods, I believe, for applying that framework.
Yes. So are you talking about like the first paper that we published and the second paper that we published?
Yes.
Or the different?
Well, no. I'm sorry. Within that second paper, I think this framework. I'm sorry. They were scenarios. I used the wrong terminology. Scenario 1 and scenario 2. Can you tell listeners what that means?
As I said, so this framework, we made this like a model that we can like put we can put different assumptions in that framework. So we make like two packs of assumptions, for putting in that framework. Scenario number 1 and scenario number 2. So scenario number 1, which was just like considering like a national-wide concentration and just like put it there. And in scenario number 2, we are like considering like a regional exposures as well. So we see that we are assuming how much in different regions it would be changed. So that's why we call it like a difference. So in the framework that we develop, we could like put different packs of like assumptions, anything that you want, and you can like get a result out of that.
And then scenario number 2, John, if you could put that map up, you broke the country into these different regions.
Exactly.
And then based on the region, you were able to differentiate, to put more precise numbers on the particulate matter in outdoor air based on the region. Does that make sense? Like some parts of the country, like the Middle Atlantic and the South Atlantic, had higher PM 2.5 than, say, the mountain area. And in scenario 2, you took that information into consideration.
Exactly. So as I say, in a scenario 1, we are just using the number that is like a national-wide average of PM 2.5 or national-wide average of like infiltration rate for PM 2.5 in the United States. And then in the scenario number 2, we wanted to see if we do our analysis like regionally, and then take find the number of the deaths in different regions and then add them together. If we are getting to the same like average number that we are using in scenario number 1 or not. So we are getting like a pretty close number. So that's why we are doing that. The reason that we are using the scenario number 1, because scenario number 1 was mostly based on like measurement studies. But in scenario number 2, it was kind of like this regional analysis was the parameters was like based on some modeling effort that was doing by other researchers. So in this study, we wanted to see regional analysis, how much it would impact on total like a number concentration if we are like doing this regional analysis in comparison to the national analysis. And we saw that the part that we have like a more polluted area, so the number of deaths is like a lot higher. Yeah. Sorry.
And that's interesting because you know, I live in this middle Atlantic area here, and the mid Atlantic area was a good bit higher than other areas. It makes sense. We, you know, the Ohio Valley's been an area for coal-fired power plants and steel mills for years. We've got a big coke plant in Pittsburgh, and we have much higher PM 2.5 outdoors than other parts of the country do. So I found that interesting. I guess I want to ask you a little bit about your HUD program. We're running a little tight on time. Before we go to that, though, I guess, can you kind of give us a final comment on this study on a framework for estimating U.S. mortality burden? What's your overall thoughts as far as where do we go from here?
From here, we are telling people that we wanted to tell you, be careful. The number of deaths which is like associated with particulate matter is high, and if you convert this like a number of deaths to the like dollars, or the dollars that we are like spending on like a health and like curing people, it's like a crazy number of like money that we are spending every year for that. So we are saying that if we are trying to reduce the exposure of people to the like particulate matter, we are actually like saving money. So we are saying that, oh, we are using like a coal for like making electricity, or like these are making lots our like a region a lot more polluted, or like our country very polluted, and then but it is causing the health. Maybe it's cheaper at the beginning, but when you are considering the number of deaths that is like making, it doesn't make, even economically, it doesn't make sense to use like this dirty source of like energy for electricity or the other sources. So we are just want to make people aware that it is like a significant number of deaths is like associated with like air pollutants, and we have to be careful about that, and we have to do something to control particles or like any kind of air pollution.
Before we go, you had asked that we mention your postdoc project funded by HUD, a very practical project where you're installing 3 types of ventilation systems for 41 selected homes. I do find that very interesting, and I'm wondering, what are the 3 types of ventilation systems that you're installing?
So the type of ventilation system that we are installing is exhaust only, which is like a continuous exhaust fan. 1 or 2 of them, based on how big is this home, is like exhaust only ventilation system.
Probably the most
other
common
one
out there, right?
Most common.
Bathroom fan and maybe a fume hood or a ring.
Yeah,
okay.
But they are not operating it like continuously. So we are like converted to like a continuously like a ventilation. That is one time. The other one are like a CFIS system, which is like introducing the air into the like HVAC system, like a fresh air to the HVAC system, and spread it through the like home after passing through the air filter, which was like an HVAC system. And the other, and it was working intermittently, so it was not like working continuously. So it was like working whenever the HVAC system was working, that ventilation system was working as well. But that was another system which was not continuous, the FIS system which was not continuous. And the other one is like a fully ducted continuous system with like ERV. So ERV is like helping the outdoor fresh air, which is like a cold or warm, when it comes inside. So it's like exchange the energy with like air which is like going outside. So the temperature would be more moderate. So when we are like into one of the complaints about the ventilation system is that it's bringing like a cold or very hot air, like a harsh parts of that. So that's why we are installing ERVs in the home to like moderate the energy. So these are three types of ventilation systems that we are installing, and we wanted to see how much they impact and like the asthma symptoms in the participants of this study. So none of these 41 homes has a ventilation system. So we monitor indoor air quality 1 year before installing ventilation system and 1 year after that, and see how much the air quality improved and how much the asthma symptoms change before and after installing the
asthma changes.
Asthma symptoms?
Okay, asthma. Okay, gotcha.
Asthma, yeah.
Asthma, yeah.
Yeah.
All right. And so you've got 41 homes. You're installing 3 different types of ventilation systems. That sounds like it's a very interesting project. And then you're looking at indoor air quality and asthma.
Yeah.
And how, I'm just curious, with the ERV, you're going to need some kind of maintenance. Are you helping the homeowners ensure that they maintain that properly, or is it just being installed and let it go?
So we are following up with them for 1 year, and we are providing air filters for them for 1 year after that, for the 2 years of air filters. But their maintenance of ERVs is not as different, as much different as HVAC system.
Right.
So if usually these homes they can maintain their HVAC system, it is as affordable and as reliable as HVAC system. So it's a new system that it's not. We are installing this system for the homes for free, but we hope that the impacts would be high enough that it would encourage people to have one of these systems at their home to reduce the asthma symptoms. If they are practical and the money that we are spending is reliable or affordable, so people would be encouraged to do that.
How far along are you in that study? Have you done the 1 year monitoring prior and now you're installing, or where are you on that?
So we just, last week, we just finished all of the installations. So, and now we are starting the second part of that, which is measuring the air quality and asthma symptoms. After installing ventilation system, we are already visited almost 10 homes after that. So, and we are continuing this study for the next year, and we keep monitoring these parameters every season. So every season we put these air quality monitors for 1 week at their home in different seasons and see how it's changing. And people are reporting their asthma symptoms through the survey to us, and we score it so to see how much it changes.
Very interesting. We'll have to get you back in a year or maybe a year and a half after you're able to get all your data together and see how it comes out.
Yeah, it would be my pleasure. I'm so excited about the result of that study as well.
Great. And before we go, is there anything you'd like to add?
No, I wanted to thank you again for having me here, and I'm happy that attention to indoor air quality is increasing maybe all over the world, and it is amazing, and I'm happy about that.
Well, great, and it's we appreciate having you, and look forward to following up Dr. Parham Azimi. And Cliff, before we go, any final thoughts from you?
I'm good, Joe. Thank you.
All right, we'll get a blog out for listeners. By the way, next Friday I will be on the road, so Cliff and I have to talk about what to do on this show for next Friday at noon. But as always, I want to thank our guest this week and my co-host, the Z-Man. Of course, John, you got to have faith at the controls. Most importantly, our growing group of loyal listeners and our sponsors as well. We'll be back next Friday at noon for the next episode of IAQ Radio Plus.
For IAQ Radio, I'm Spike Reed saying thanks for listening.